Hello, my name is Mike Booth, and I'm the Technical Director at Inorganic Ventures. Today I'm going to talk to you about a new platinum cobalt color standard that we've developed and sort of walk you through the process of how it's developed, how it's certified, and how it can be used. Testing for color is a pretty common method performed on a wide variety of water sample types. Samples are measured against a standard of known platinum and cobalt concentration that together are calculated to form a color unit value. Historically, the color of water samples were judged off a description of water white or a totally clear solution with no color present. Okay, so if you dive into the methods listed on the previous slide, you'll see that a 500 color unit standard is made of about 1 gram per liter of cobalt chloride combined with a little over 1.2 grams per liter of potassium chloroplatinate and 10% HCl. So a lot of labs will make this standard in-house, sort of on the bench, because the recipe is pretty straightforward. But there can be some disadvantages that should be taken into account and considered when making this up in-house. The first off is the accuracy of the aliquot weights. 1 gram is not a very large aliquot weight, especially if you're using a balance that doesn't go to 3 or 4 decimal places. So if you're off by a little bit, it only takes about 0.01 grams to throw your measurement off by 1% on these aliquots. So you want to make sure that your balance is up to spec for what is needed for these. Secondly, you want to make sure that the starting material, the purity of that is very accurate and known. So if you are calculating or if you're using a material and the purity is not what you expect it to be, that can throw off that 500 color unit value as well. And lastly, the starting material also needs to be homogeneous throughout. So you want to make sure that there's not a difference from, say, the container of potassium chloroplatinate, the material at the top of the container versus when you get down to the material at the bottom of the container. So what we've done at Inorganic Ventures is we've essentially taken this recipe for a 500 color unit standard and converted into concentrations of cobalt and platinum in parts per million. So doing that conversion, this puts it into a material that we're very familiar with our regular CRMs. And we followed the same approach. So essentially what we've done is we've calculated that a 500 CU color unit standard contains 250 ppm of cobalt and 500 ppm of platinum from those starting materials. So now that we have that information, before we actually make the final blend, we want to eliminate some of those disadvantages that we just spoke about concerning starting material purity and homogeneity issues. So we actually take each starting material and create 2 separate concentrates. So concentrate 1 is about 50,000 parts per million cobalt made from that cobalt chloride. And concentrate 2 is about 40,000 parts per million platinum made from potassium chloroplatinate. And then from there, we will certify those concentrates and then use that to make the final mixture of 250 ppm cobalt, 500 ppm platinum, which gives you that 500 CU color unit value standard. So as I mentioned, the 2 separate concentrates that we make, the one for cobalt and the one for platinum, are certified. So to certify those materials, we do an ICP assay on each lot, traceable to their respective NIST SRMs, which are listed on this slide here. This traceability guarantees the accuracy of the concentrate so that we can continue that through to create the final 500 CU color standard. So following the method that I've described, it really allows us to address all the disadvantages that I spoke about earlier. The accuracy of the aliquot weights, since we are creating a concentrate solution of the platinum and the cobalt, we're able to, when we make lots of the final blend, our aliquots are much larger than just 1 gram of material. So that allows us to make sure that we have extremely accurate aliquots based on our normal manufacture of certified reference materials. And again, in making those concentrates, it also allows us to eliminate any of the issues with material homogeneity, since the entire material is brought up into a liquid form. And the purity is also not a concern since now we have NIST traceable values on the parts per million of cobalt and platinum that we'll use to make the final blend. Also, having that NIST traceability allows us to make a final product that's 17034 accredited, which is another sort of benefit to this product. So on the certificate of analysis for this product, you'll find the certified values of platinum and cobalt and the calculated color unit value, as well as you also find some information on the UV-Vis spectrometer measurements that we've taken of the lot itself. So on each C of A, you will find a chart like this that shows our readings on our UV-Vis of the 500 color unit standard run straight, a 1 to 5 dilution, and also sort of a running of a NIST SRM 2034 for a wavelength check. So that information is included on each certificate of analysis, along with a table that includes some information on absorbances. So we check our UV-Vis spectrometer against SRM 931H to make sure our absorbances are lining up with where they should be. Those values, again, are for your information only and not really certified, but the more information you have about this product, the better. So to summarize and just provide a few other tips on color testing, we really believe that the product that we have designed, the 500 color unit standard, is superior because of the platinum and cobalt certification by ICP assay. It really gives you, make sure that the product is reliable from lot to lot, which we have seen we've heard issues with when people make it up at the bench, and it's probably not through any fault of their own. And again, it's probably those disadvantages that we spoke about earlier, the aliquot weights and the homogeneity and purity of the starting materials. But through our process, we're able to make a very reliable product, and we provide a lot of information on the certificate of analysis. Just a few other things about the method itself. Our standard does not need to be filtered since there are not any suspended solids, but if your samples have suspended solids, that will provide an interference for this testing method. So if you're running into issues, you may want to filter your samples, but our standard is free of any particulate. And just a little mention on detection limits. I mentioned before that we provide information from our UV-Vis spectrometer. All that information is captured using a 50 millimeter cell. So you could achieve lower detection limits by increasing that path length. Always keep in mind Beer's law, where your absorbance is directly related to the concentration of the sample and the path length. So if you go to a shorter path length, even with a shorter path length with a lower concentration, it's going to give you a lower absorbance, affect your detection limit. But if you have a lower concentration with a pretty long cell length, you can still get a pretty decent absorbance value. So that is going to be it for this. If you have any questions, please feel free to reach out at info@inorganicventures.com, and we'll get a response back to you as soon as possible. And I thank you for your time.